Multimeters. I did a stupid. While I was on holiday, I was using this little meter, just a cheapo thing. I bought it because it was green, and I was trying to measure the short circuit current of a solar panel, and I connected it across the panel, but forgot to disconnect the big battery first. So I got a short on it. The buck regulator was conducting power from the battery through the meter, and it popped. So I'm hoping it's just the internal fuse. Now I can check it's popped, I can show it's popped. On a working meter, if you measure from common to the 10 amp, you get continuity. So that cheapo meter is still fine, but this one, nothing. So let's have a look in this. See how bad it was. It does say that it's fused. It says on the front, fused 10 amps. Long life. Feel the quality on that one. Okay. So here are the fuses. It's marked 250 milliamp. Go down a bit closer. So two fuses in here, 250 milliamp and 10 amp according to the writing on the board. Check that one. That's okay. So the 10 amp fuse is okay. That means something else went bang. So this is the current shunt. So we go from the 10 amp terminal up to the fuse. That's still good there. So from the terminal to the fuse, to the other side of the fuse, but not back to the common. So, something on the other side of the board, between there and there, went gone. Let's take it apart and see what happened. We were on holiday and camping. I had the solar panel set up, and it puts out a couple of amps, and I was just trying to see what position it worked best in. So I connected the meter across it and I've moved it around a bit, and yeah. Oh, more screws. I didn't realise that the power supply, well, the power regulator that I was using for the battery charging, would conduct so much current. And normally when I tested it, I'd have a resistive load on it. I'd just turn on camping lights and things and see what the voltage was, and there we go. Oh, lovely. And where was I? Oh yeah, anyway, the meter went across the solar panel and it got a jolt off the battery, which has blown this up. So here we see, here's the bottom of the fuse holder, 10 amp terminal, fuse, and this track has protected the fuse by burning out. Now I can see there's a trace comes down here to that side of the shunt, so this little trace here, so that's going to be where it's measuring the current between there and there, which means I can just bridge these two with anything that'll take 10 amps and we should be good. Special. Right. That's no good to anyone. Chop it off. Solder braid. Good stuff, will handle a few amps. And it's nice and thin, so I reckon it's a braid from there to there. That'll fix it. Yeah. Proper bodge. Should we test it with a millimeter before we put it all back together? No, it'll be fine. It'll be fine. Go on then. Kidding. So let's get a test on, get a load on this. Where's my load? Right then, we've got Ambland power bank, big resistor, excellent, it's showing 4.5 volts, nearly an amp. That's not bad, I think that survived. So the solar panel thing, I have the big panel and I think it's 110 amp hour lead acid battery, and that one solar panel and the battery usually will be enough to keep us going for a couple of weeks while we're camping. That'll do lights and charge phones, and actually powers a fan. We've got a gas powered fridge that's got an electric fan in it to make it work a bit better, so So power that off it. Laptops and GSM kit. We do actually also have a wind turbine, which is a bit big and heavy to lug around, and it's a pain putting the mast up. But if we're going to be somewhere windy, especially if I'm going to be going there working and I'm having the laptop on for hours a day, that's quite good, because the wind turbine will charge the laptop directly, get 20 volts out of it fairly easily. But generally we take it down to about 14 volts, charge the lead acid, and then just a little boost converter for the laptop, or depending which laptop it is. This one I'm recording on at the moment's got a 5 volt input. I can't get his coat back on. Am I doing it the right way? I think so. Get on! Get! Ah. Yeah, that works. That's it. Okay, even though it's green, I'm regretting this silly rubber bumper thing. Maybe just go on the other way. Oh no, it can't do that. That must be the right way. It's just a bit deformed. It'll be fine, it'll be fine. That's ready to go back in the camping box.